before we go to that technique in getting the derivative of this trig function, let's have first other ways in getting its derivative. Notice that using the law of exponents with regard to negative exponents, cosine x raised to negative 1 is the same thing as 1 over cosine x. And using a trig identity, this is actually equal to secant x. And so, when getting the derivative of cosine x raised to negative 1, this is the same thing as getting the derivative of secant x. And yes, its derivative would be secant x tan x. Let's now apply our technique in getting its derivative using chain rule. We have a separate video on how to make use of this technique, so if you want to review that, just click the I icon there for that suggested video. It's preferable to watch that video first because it's being discussed there on what the red and blue marks would represent. That is, red marks would be for the outer function while blue marks would be for the inner function. As noted in that suggested video, we have to get first the outer function's derivative, and then we multiply this to the inner function's derivative. The derivative of the outer function would be negative 1 times the inner function, and our exponent this time would be negative 1 minus 1, which is negative 2. Next would be the inner function's derivative. In this case, our inner function is cosine x, and its derivative would be negative sine x. And yes, the algorithm in using this technique would just be multiplying the outer function's derivative to the inner function's derivative. Simplifying these expressions, we'll now have positive sine x times cosine x raised to the power of negative 2. And using the concept of negative exponent, cosine x raised to the power of negative 2 will now be part of the denominator. Notice that this is the same thing as sine x over cos x times 1 over cos x, and using trig identities, this would now be tan x times secant x. Clearly, this is the same answer that we got earlier. Now let's have the general way of doing the derivative of trig functions. Observe that after getting the derivative of the trig function, we still have to multiply this to the angle's derivative. In this case, let's consider the trig function to be our outer function and the angle to be our inner function. So for visual learners, let's rewrite sine 2x in this manner. Thus, the derivative of sine 2x would be 2 cosine 2x. To check if our answer is correct, let's have another way of getting the derivative of sine 2x. Using the double angle formula, sine 2x is the same thing as 2 sine x cos x. So when getting the derivative of sine 2x is the same thing as getting the derivative of 2 sine x cos x. Using constant multiple rule, this would now be 2 times the derivative of the product of sine x cos x. So for the derivative of sine x cos x, using product rule, this would now be sine x times the derivative of cosine x, which is negative sine x, plus cosine x plus this time the derivative of sine x, which is cosine x. If you want to be reviewed on how to do product rule, just click that suggested video about differentiation rules. Simplifying this, we now have 2 times negative sine squared x plus cos squared x. However, using the double angle formula, cosine 2x is the same thing as cos squared x minus sine squared x, and so this is the same thing as 2 times cosine 2x. And yes, our answers are the same. How about for this function? Do you think its derivative would be 2 tan x? Let's have some verifications. Notice that when we say tan squared x, this is the same thing as tan x times tan x. And so to get its derivative, we can actually use product rule. Clearly, we have different answers here. Therefore, you shouldn't use power rule in getting the derivative of tan squared x. That is, if we have higher order functions for trig functions, we still have to use chain rule. Notice that when we say tan squared x, this is the same thing as the square of tan x. And so we can actually rewrite it this way. And so applying chain rule by inspection, we first get the derivative of the outside function. That would be this time 2 times the inner function tan x times the derivative of the inner function, which is the square of secant x. And there, the answers are the same. So let's generalize this type of trig functions. If we have trig functions of higher orders, such as our example tan squared x, careful about identifying the outer and inner functions. That is, in this case, the red marks would be the outer function and the blue marks would be the inner function. Let's check if you got the gist. Try to get the derivative of sine cube x. Observe that in sine cube, the inner function would be sine x and the outer function would be the cube part. And so, its derivative would be 3 sine squared x, which is the derivative of the outer function, times the derivative of the inner function, which is this time cosine x. How about this one right here? Let's widen your horizon. Notice that for 3 tan squared 5x, we can consider it this way. And so for outer function's derivative, it would now be 6 tan 5x. And yes, this will still be multiplied to the inner function's derivative, and the inner function here is tan 5x. In getting the derivative of tan 5x, observe that we still have to use chain rule here. That is, the outer function would be tan and the inner function would be the angle 5x. And so the derivative of tan 5x this time would be the derivative of tangent, which is secant squared 5x, and the derivative of the angle 5x, which is just 5. Simplifying this gives us now 30 secant squared 5x times tan 5x. Similarly, for this function, we can have it this way. So getting the outer function's derivative, or the red marks here, we now have this. And as for the derivative of our inner function sine 5x squared, notice that we still have to use chain rule here, and so the outer function here would be the sine function and the inner function would be the angle 5x squared. Thus, the derivative of sine function would be cosine function. That's why we have here cosine 5x squared. And then we have to multiply this to the inner function's derivative, in this case the derivative of our angle 5x squared, which then gives us 10x. And finally, simplifying this, we now have 120x sine 5x squared cos 5x squared.